This is Mr. Khamitkar, working as an assistant professor in the Department of Electronics and Computer Engineering, Walchand Institute of Technology, Solapur. Now, we are continuing with this online EDA tool. This is like the fifth video that I am making it for understanding these tools. So, we have started to understand what is mean by EDA tool and how it can be used. What are the different components that we can place on. So we started with introduction. We had taken it into the consideration in the small LED interfacing. Later we jumped into the part of understanding the interfacing of LDR, and apart from that the different tools. So we will be continuing with this. In this particular session, what we will be taking it through is we'll be talking about utilizing the online EDA tool to interface the ultrasonic sensor. This will be the video for interfacing the ultrasonic sensors. And the other one, the next video, we will be talking about interfacing of relay. So let's take it through the hands-on directly on the link. So if I go to the tool, so this is the platform that we are utilizing since our start of these series. So we'll be continuing on it. So what we have here is a 4-pin ultrasonic sensor. You can see that there are like terminals. You can see VCC, then the trigger, and then echo and the ground. So basically your ultrasonic sensor works on the sound waves. So whatever sound waves travel through this particular sensor, if it strikes on some kind of an object, if it comes in front of it, it strikes on it, and that sound waves, ultrasonic sound waves, which are at order like more than 20 kilohertz, because they are not audible, they are in ultrasonic range, they come back. So we will be triggering that, and whatever the echo coming up, so as we know that the speed of sound that travels, so using that formula we can take the time into the consideration and evaluate how much is the time taken by the signal to travel from like start by sending this trigger, and when the echo reaches back, it collects it, and by collecting it we can calculate the difference. And if I divided that time and take it into consideration with the speed of travel of your audio signal, then simply we can calculate the distance of the object or obstacle from that particular. So if I show you the connection, now this particular pin number 7, pin number trigger is connected to pin number 10, and the echo pin is connected to pin number 9. So we'll be talking about the program also. So the VCC is connected to the 5-volt supply, and the ground is connected to the ground of Arduino board. So this is the connection that we have for ultrasonic sensor. Now let's take into the code part. Now as defined, the trigger pin is defined it as 10, echo pin is defined as 9. Then there is a time, whatever time it takes from like the trigger part to reach it and comes back as an echo. So that is the time, and we will be ultimately calculating the distance out of it. So in initial setup for this particular pin, the trigger pin will be taking it as an output from which we will be triggering that sound waves. Then echo pin is where we will be collecting it whenever there will be a echo received from that particular pin. So the distance whatever we are going to get, we will be monitoring it through a serial monitor that we have discussed about it earlier also. during the LDR interfacing. The serial port is majorly used for debugging even the communication standard using RS-232 protocol. It works with serial communication. So 9600 is the baud rate that we will be initializing it with. Now, in case of loop, what we want is we particularly want this particular digital write on the trigger pin. We will be writing it low. Then we'll be taking a delay of 2 microseconds. Then we will be sending an high pulse and we'll be taking the delay of 10 microseconds. So likewise, we'll be writing it up, and so 10 is again a low. So we made it the pin as a low. So what it means is we are sending the pulse of 10 microseconds on this particular in continuation. So with continuation on this particular pin, this pulse, when we will be sending it on the trigger pin, what it will do is it calculates the pulse coming back to the echo pin. So whenever there is an object coming in front of your ultrasonic sensor, that sound waves comes back, and that can be collected through this particular pulse in. So using pulse in, what we will do is this particular echo pin is read, and we will calculate that how much is the time taken by pulse to go and come back. So with this calculation, what we will get it as the total amount of time traveled by the sound wave. Now using this particular formula, where we'll be multiplying it with this 0.034 and divided by 2, we'll get the distance of that particular object from the ultrasonic sensor. Now finally what we will do is we'll print the output of this particular distance on the serial port, and we'll checking out that distance from this particular, so printing that particular distance of the signal. So object at what distance it is there will be displayed on the serial port. We'll show the demonstration first, and we'll again discuss few of the changes that we can make into this particular program and how to get it. So if I click on this, I will take it up. I will set this particular thing apart, because when we simulate this, we'll get. So we'll start the simulation. We'll see into the code part also, because this is the serial monitor where we are going to get the distance. So if you could see that the distance it is showing is around 124. So you can see that this particular object, when we select the ultrasonic sensor, it is around 124.5 centimeter. So if I change this particular distance, so it is around 169.8, and we are getting around 169.7. So it's 0.01. There is a change. But what we can calculate here is, as we change this particular sensors, like the object's distance, it follows. If I take it into consideration now, 199.6, it is around 199.5. Likewise, we will be getting that values of the sensor that we are interested in. Now, what are the applications for this particular ultrasonic sensor? So the ultrasonic sensor can be checked upon. There are so many different applications. When we are talking about the autonomous robots or autonomous vehicles, these kind of sensors help to understand the controllers to understand about the surroundings, what exactly are there around the surroundings. So if you consider this, is what we have done is we have taken into consideration and this particular distance that can be seen up. So we'll be continuing on utilizing this particular ultrasonic sensor along with the next relay, and in the coming videos we'll make it a part of it, and using this how we can display it. So thank you so much for listening and taking your time. Thank you. Thank you once again.